Assalamu alaikum dear students, I hope everybody is fine. I am Dr. Ali Abbas and you are watching YouTube channel A Level Camps. In this lecture we will discuss the rational functions and their graphs. So student, like we define the rational number p by q provided p, q are relative prime, q non-zero and pq belonging to the integer. Let's say this is a rational number in the form of a fraction. Similarly, we will define the rational function p of x, q of x, where p be a function of x and q be a function of x. So for example, you can take provided q of x is non-zero. Maybe you can take the function, for example, 1 over x square, 1 over x minus 3, 1 over x minus 3 plus 2. So student, when you draw this graph, you will see it will be like this one. If you draw this graph, you will have like this one. And if you have this 1 over x minus 3, so you can see that here you can write x minus 0. It means the vertical asymptote is x equal to 0. Here the vertical asymptote is at x is equal to 3. So you can plot this graph as, let's say this is 3. You can plot this graph like this one. Understand? And similarly, if you have plus 2, then lift graph at 2 and the new graph plotting will be like this. This is green, this is red and this is green graph. Understand? So student, now we will study how we have to check their behavior for horizontal asymptotes, vertical asymptotes, and these all asymptotes and oblique asymptotes also. These all asymptotes, the x-intercept, y-intercept, their turning point, help us for the sketching of graphs. So for sketching, we check firstly the x-intercept and y-intercept. For x-intercept, substitute y equal to 0 and solve for x. So you will get the x0 0 point, that is the x-intercept. And for y-intercept, what you will do, you will substitute x is equal to 0 because at y-axis x is 0 and solve the expression for y. So let's say point you will get 0 y0. For the second point, we find horizontal asymptotes. So for the horizontal asymptote, let's say you have y equal to some expression. So what you will do, you will take limit at x approaches to infinity, means you are checking the behavior of the function for very large value of x, and when you will solve it, you will get some value. Let's say the function approaches to any definite number, let's say maybe 0, maybe 1, maybe some value of x, say in general x0. That is, for the horizontal asymptotes, what you will do, you will take limit of the function and you have a value x0. And similarly, for vertical asymptotes, you substitute a definite value of x, means you are taking the limit of the function at some point and you will get infinity, maybe plus infinity, maybe negative. And similarly for the horizontal asymptotes, you can substitute plus infinity and minus infinity. Student, what about the oblique asymptote? So for oblique asymptotes, what you will do, you have a function in the form of rational, means you have a function maybe q of x over p of x, where the denominator function is non-zero function, and this expression must be the improper fraction. For example, you have x square minus 1, x into x plus 1. So student, maybe you have this function x square minus 1 over x plus 1 plus 2. So you can see that this is an improper fraction. So in the form of improper fraction, you must have the oblique asymptotes. So when you will solve it, you will get let's say this is y, you will get x minus 1 plus 2, the resultant is x plus 1. So x plus 1 is your oblique asymptotes for this function. Now we will do some of the questions in which we have to find all the asymptotes, horizontal, vertical and the oblique asymptotes. Thirdly, student, we will find the stationary point. For the stationary point, you know that we substitute the derivative equal to 0 and we will get a stationary point, and solve this expression and we will get the stationary point. At this point we find the value of the function. Let's say when you substitute x0 in the given function y equal to f of x, you will get y0. So the stationary point are x0, y0, maybe one or maybe more than one stationary point. So lastly, we are able now to sketch the graph and then we sketch the rational function.